All right, so we are going to talk today about crystal hydrates, and these are a special type of compound that we kind of really briefly started talking about. But a crystal hydrate, or a hydrate, is an ionic compound in which the ions are actually attached to one or more water molecules, okay? So a way to think about this, right, we said that ionic compounds have this positive, negative, right? And it's got this repeating pattern of positives and negatives. But sometimes when we make that compound, right, we actually get some space in those positives and negatives, and in that space, we get a water molecule. Okay, so I can draw some of my water molecules here where they're kind of mixed in between the positives and negatives. Okay, so what ends up happening is we have a formula where we have positives and negatives with water stuck in between. So our formula has to indicate that we have that crystal lattice with water molecules in between, right? So we notice how water molecules are built into our chemical formula, okay? Again, our chemical formula is trying to describe, as best we can tell, what is actually happening with our particles, okay? So when we remove that water, right? We can remove that water by maybe heating it up enough. That's going to make the water boil. It'll get out of the lattice, and we will be left with just our positives and negatives. And so that's going to be called an anhydrate. Or an anhydrous compound. Okay, hydro, water, hydrous, but anhydrous, meaning that we've removed the water, okay? So these are a type of compound that we're gonna talk just a little bit about, but what we can say is we can do some problems like this, okay? So this problem says, what is the percentage by mass of water in sodium carbonate crystals, okay? So this would be sodium carbonate hydrate, rather than just sodium carbonate crystals. I'm going to call this the hydrate, of course. And we've got 10 water molecules that are attached in our compound. Attached to each, for every one sodium carbonate, we've got 10 water molecules. So what we can do, first of all, if we have our actual formula, we can just get our percent by mass. Okay, so sodium, just the exact same. We're going to do 2 times 23, that's going to be 46. Carbon, we've got 1 carbon there, so that's 12. We've got 3 oxygens in our carbonate. If we remember, carbonate would be CO3 2 minus, right? We should remember our polyatomic ions. So 3 times 16, that's going to be 48. And then we've got 10 water molecules up here, okay? So we're going to have to do 10 times each of our water molecules. So we've got 2 times 1 for the hydrogen, and then we're going to add 16 for our oxygen there. So that altogether is going to be 180. And so our mass, the formula mass for our whole hydrate is going to be 286. Okay, if we add all of those numbers together. Okay, so then we can look at our percent composition, look at our formula. We're going to do percent of water by mass. Okay, so our mass of water in this was 180. And then our total is 286. And then we're going to multiply it by 100, and that gives us 62.9%. That if we measure this out, 62.9% is actually just water in there, okay? But we can also do a different type of problem. What if I said we have 62.9% of a hydrate, that is water, and 37.1%, that is the sodium carbonate. What we can do is exactly the same as our empirical formula and actually identify what the hydrate formula is, okay? So what we can do is we can take our percent to mass, mass to moles, and then divide by the smallest number, and that's going to give us our hydrate formula, okay? So really, we can think of this as just another type of empirical formula, except that in this empirical formula, we've got one ionic compound and 10 water molecules, okay? So let's see how we can do that, right? We're going to take our percent to mass, so we're going to do 62.9 grams of water and 37.1 grams of sodium carbonate. We're going to convert that to moles. So we did percent to mass, mass now to moles. So 18 grams of water to 1 mole of water. And that's going to give me 3.49 waters. And then I have 37.1 grams of sodium carbonate. I'm going to divide by 106 grams of sodium carbonate because my molar mass of sodium carbonate is 106. I can do 37.1 divided by 106, and that gives me 0.35 moles of sodium carbonate. So then, right, I would divide by the smaller number. So 3.49 divided by 0.35, that is going to be roughly 10 to 1. So now we see for my 1 sodium carbonate, I've got 10 water molecules. What was my hydrate formula? Oh, look at that. It's 1 sodium carbonate to 10 water molecules. Okay, so now we should be able to do our practice questions on the next page. We should be able to do some of the hydrate worksheets.